Here we study about the interaction between any radiation with matter. As we know, different frequency of a radiation will carry different energy, and that energy will interact with a particular dimension of the matter. For example, uh, a radio frequency has very low energy and it will interact with only the nuclear spin state. It will only gets absorbed in the nuclear spin state, and the higher energy, for example microwave energy, it will be responsible for the transition in the rotational energy levels, and further higher energy like IR, it can get absorbed in the vibrational uh, energy levels, and so on. Further, even higher energy level like UV visible energy will be absorbed in the electronic states. So we see that a different kind of frequency will interact with a different dimension of the matter. In case of NMR spectroscopy, we use radio frequency as a energy source, and any nuclei with having nuclear spin non-zero, it can be half nuclear spin or greater than half. These nuclear spin, non-zero nuclear spin, will be magnetically active, because we know that any charged particle, when it spins, it also creates a magnetic field. So that magnetic field, whatever magnetic field it will produce, it can interact with an external magnetic field. So this is the basic interaction. We need a magnetically active nuclei. There are many magnetically active nuclei, but we mostly study proton. It is mostly abundant in nature, out of all the hydrogens. H1 is about 99.98% in the nature, and deuterium or tritium can also be there in small portions, but most of hydrogen is in proton state. So it is the natural abundance of proton. And the other important parameter is the gyromagnetic ratio for this proton. We will talk about gyromagnetic ratio a little bit later. Its I value is half, and there are other magnetically active nuclei which we will study in more detail, all having I value half. I am also writing the natural abundance for these nuclei. So these nuclei will be studied in more detail, and there are other number of nuclei where they can also be magnetically active, but I equal to half value, the nuclei with the I is equal to half value are more important. Why they are more important, that also we will be discussing in a short time. So basically what happens, the basics of how and why any magnetically active nuclei show NMR signal. So as we saw that nuclei having a spin, if they have a spin, let's suppose like this, they will also create a magnetic field. Okay, but if they spin in the opposite direction, they will also create a magnetic field in different direction. So the magnetic field will vary according to the spin. So two type of magnetic field will be there. One will be in the one direction, and other will be in the reverse opposite direction, right? So when there is no external magnetic field, these two energy states, that the nuclear magnetic field can remain in either direction, either up or down. Okay, but in when magnetic field is applied in a particular direction, say this, then the orientation of these magnetic fields from spin, the orientation of these two orientation will not have the same energy, because the one in magnetic field in the opposite direction to the applied will be of higher energy, and the one which is in the direction of the applied field will be in lower energy. As I value is only half, there is only one particle. We are talking about one particle, so one particle will either remain in lower energy or in higher energy. So when it is let's suppose it present in a lower energy, and then this is the energy gap that has been created. This gap will be covered by the energy, will be covered by the absorption of energy. That energy will come from the radio frequency. So this is how energy gets absorbed, and this nuclei, the magnetic field of this nuclei will change its directions, will change its direction to go in the higher energy state. So it will even go in the higher energy state and in the opposite direction to the applied field. This is how the absorption of energy takes place. But after absorption, it has to come back to its ground state, right? So when the nuclei come back to the ground state, because it is charged, and whenever it comes down to the ground state, it will release a electromagnetic radiation. The charged particle, when from higher energy, when it comes to the lower energy, it emits electromagnetic radiation. This is the law. So this EM radiation then converted to by means of Fourier transformation, and Fourier transformation convert this signal into a different type of peaks. This is the spectra we see as a result. This is the spectra that we see as a result. Okay. Further, after this basic talk, just a basic talk, we will talk about the precessional frequency. See, when we had these two states without any application of magnetic field, and after the application of magnetic field, we see that the energy gap is there between the two states. But this nuclei, this magnetically active nuclei, under the influence of applied field, this the magnetic vector will also process around this direction. It will not only stay stationary as this, but it will keep on processing like this. It will just rotate like this, right? The direction will keep on processing. If the direction will keep on processing like this, it must have some cycle per second frequency that we measure in hertz, cycle per second. It will rotate in cycles, and whatever cycle it will take in a second, in 1 second, it will be the frequency in hertz. It is important to note here that when the field is increased, this precession will get faster. It will also increase. So if it is precessional frequency we can write with omega, then applied field will be proportional to omega, or omega will be proportional to applied field. Right? This is important. Further, another thing, if this field is increased, then the gap will also increase. If the external magnetic field is small, then this gap between the two states will also be small, and this external magnetic field is large, then this gap will also be large. So here the precession at this state, the precession will be very fast, okay, and at this state the precession will be slow. So you can see that the energy gap, the precession, cycle per second, and the applied field all are connected. So we know that the nuclear spin in the ground state will also process in some cycle per second, and it is dependent on the applied magnetic field. So simply, if we say that